In this video, we're going to talk about ellipses. An ellipse is a set of points such that the sum of the distances from any point on the ellipse to two fixed points remains constant. So these fixed points we call foci, or the singular version is focus, but the plural version is foci. Yes, it's kind of a fun word. So then D1 plus D2 remain constant for all points on the ellipse. So D1 here and D2 are the same for all of the points that you pick on your ellipse. We have some different things versus we did with circles. So the major axis is the longer axis of symmetry, and the minor axis is the shorter axis of symmetry. The center is still the center. It's the point where the major and the minor axis intersect. And the vertices are the endpoints of the major axis. And then the co-vertices are the endpoints of the minor axis. So there are two types of ellipses, a horizontal ellipse, and we're going to label this horizontal ellipse. So this thing right here we call the center, just like we did with circles. Since it's a horizontal ellipse, that means our major axis is horizontal. So that means this is a vertex, and this is a vertex. These points next to the vertex are called, there are foci, or the focuses, which is not correct English, so don't go telling English teachers on me. This up here, we call a covertex. And this is also a covertex. So that's how you would label a horizontal ellipse. And if we wanted to label a vertical ellipse, the only difference is it's vertical instead of horizontal. And then our vertices and covertices will change. So our covertices will be the ones on the horizontal axis. Our vertices are on the major axis, which is vertical in this case. Our center is still the same, and these are still our foci. But the couple things that change is our focus moves with our vertices. So if it's a vertical ellipse, your foci will be on the major axis, which is vertical, and then if it's horizontal, your foci will be on the major axis, which is horizontal. So the vertices are plus or minus a units away from the center, and the covertices are plus or minus b units away from the center. Your length of your major axis is 2 times a, and your length of your minor axis is 2 times b. And then your foci are plus or minus c units away from the center. So to find your foci, you use c squared equals a squared minus b squared. This is not the Pythagorean theorem. Just be aware of that. It is not the Pythagorean theorem. And a is always going to be greater than b. So if I wanted a standard form with my center at 0, 0, it would be x squared over a squared plus y squared over b squared equals 1. It is always equal to 1. And then that's for a horizontal one. And then if it's a vertical one, you got x squared over b squared plus y squared over a squared So it determines, since A is always greater than B, if A is over the X, it's a horizontal, and if A is over the Y, it's over it's a vertical. Standard form with the center at some other point other than 0, 0, or HK, is X minus H squared over A squared plus Y minus K squared over B squared, all equal to 1. And then that's if it's horizontal, and then if it's vertical, we have X minus H squared over B squared plus Y minus K squared over A squared equals 1. So we do ellipses next because they're the most similar to circles. So now that we have all this information, we are going to use that information to graph them. So we're not going to do all of these on here. We'll probably do the odd ones. And then there will be a couple where we have to complete the square as well. So here we are going to, well, this is A squared and this is B squared, because A squared is, A is bigger, so this is going to be a vertical ellipse. And my center is at 0, 0, because I have no H and K up top. So if A squared is 36, then A is 6, and B is squared is 4, so B is 2. So now I'm going to find C. So I'm going to take C squared equals 36, which is A squared, minus B squared, which is 4. So C squared equals 32. So C equals square root of 32, which is about 5.66, and we'll just round to 2 decimal places. And so since our center is at 0, 0, this one's easy. We're going to take and plot a point at 0, 0. We're going to plot our center. To find our vertices, you are going to take 0 plus or minus A, which is 6. So if I wanted to write this in 2 points, it would be 0, 6 and 0, negative 6. So 0, 6, let's plot that on there. And I'll do those in blue. Just so you can see that they're different. So those are my vertices. If I wanted to find my co-vertices, B is 2, and you're going to add them to your x-coordinate because it's a vertical. So I'd have plus or minus 2, 0, so negative 2, 0, and 2, 0. And I'm going to plot those in this coral color. So there's my ellipse. I just got to figure out my foci before I finish this. So my foci they go along with the major axis, which this case is vertical. So I'm going to add them to my y coordinate, which is plus or minus 5.66. So I'd have 0, 5.66, and 0, negative 5.66. So I'm not going to graph them on there because they don't graph very easily. However, you can if you would like, but I'm going to draw an ellipse now. Hopefully it'll work. It doesn't have to be perfect, as long as your points are right, it's okay. So that is how you do that with a vertical ellipse. We are going to move down to number 3 because, as you can see, my center is not 0, 0 in this case. My center would be negative 1, 2. And this one is horizontal because a squared is under, the bigger one is under the x. So a squared is 49, so a is 7. And b squared is 9, so b is 3. All right, so this changes things a little bit. Before we go solving for C, let's find our vertices. So since it's horizontal, it's going to change the x. So the y won't change. It'll be 2 in both of my vertices. And then I need to add 7 to -8. So that'll give me 6. Then I'm going to subtract 7 from -1. So I'm going to get -8. And I think earlier I said I'm going to add 7 to -8 instead. I was jumping the gun. So this is plus or minus 7 to find my vertices. And then to find my co-vertices, my x-coordinate will stay the same. And then I need to add 3 to my y-coordinate, so I get 5. And then I'm going to subtract 3, and I get -1. So if I want to graph these, let's graph my center first. Sorry, I'm jumping. And I'll do blue for my vertices. So there is my ellipse. And then to find my foci, I need to do c squared minus a squared, which is 49, well, equals a squared minus 9, so I get c squared equals 40. So c equals, 40, so which is about 6.32. So my foci will be along my horizontal axis. So I'm going to change the center. I'm going to add 6.32 to the x-coordinate of the center. I'm going to get 5.32 and 2, and then I'm going to get -7.32 and 2. So that's how you graph a horizontal one with the center not 0. Let's move along. Let's do number 6 and number 7. And we can do number 8 too. They're all a little bit different, so let's do all 3 of those. So 6 is not equal to 1, so I need to get it equal to 1 first. So what I'm going to do is divide everything by 144. So, and then I'm going to simplify. 9 divided by 144 simplifies to 1 over 16. So I have x squared over 16, and then 16 over 144 is 1/9. So y squared over 9 equals 1. So that's my standard form now. Now I can find all the other things that I need to. So my center will be 0, 0. My vertices, well, it's going to be horizontal because the 16 is bigger over the x squared. So a is 4 and b is 3. And then I want to find so c equals the square root of 7. So I'm going to add plus, which the square root of 7 is about 2.65. So I'm going to be adding that to the x-coordinate. So I'm going to have plus or minus 2.65, 0. And it's easy when your center is 0 because you can write it this way. However, your center will not always be 0. So vertices will be plus or minus 4, 0, and then co-vertices plus or 0, plus or minus 3. And then you can graph it from there. I'm not going to graph it for you. You don't want to watch me count. So then this one, we're going to use completing the square like we did with the circles. So we're going to combine, put all of our x's on one side all together with a blank. And then we're going to plus 4y squared equals negative 9 plus something else. So negative 10 divided by 2 is negative 5 squared is 25. So then I'm going to factor this. So x minus 5 squared plus 4y squared equals 16. And this is when I need to divide everything by 16 because I have to get it equal to 1. So 4 divided by 16 is 1/4. So y squared over 4. And then x minus 5 squared just hangs out over 16. And then from here, I'm going to let you do it to find all of the other information. I just did the hard part for you of completing the square. Same with 8. I'm going to show you how to complete the square, but I'm not going to do all the other information for you. That's going to be for you to do. So I'm going to group all my x's together and all my y's together. So I'm going to have 4x squared minus 32x plus y squared plus 8y equals negative 76 because I wanted to move that to the other side. So since I have a 4x squared and I just want x squared, I can factor out a 4. So I have x squared minus 8x plus something plus y squared plus 8y plus something else equals negative 76 plus 4 times whatever that same something is I added over here, I have to add there. Since there's a 4, I have to multiply it by 4. And then I'm going to add whatever I add to the y squared part. So half of 8 is 4, negative 4. Squared gives me a 16. So 16 also goes there. Then half of 8 is 4. And then 4 squared is 16. So I added 16 in both places. That's okay. When I factor this, I'm going to have 4 multiplied by x. Now I have to factor minus 4 squared plus y plus 4 squared equals 4. When you add them all together, you get 4. So now I need this right-hand side, this thing right here, equal to 1. So I'm going to divide everything by 4. So these 4's go away, those 4's go away. So I have x minus 4 squared plus y plus 4 squared over 4 equal to 1. So that is that ellipse in standard form. But you need to determine the center, the vertices, the co-vertices, the foci, and graph it.